In today's environment with disposable consumer electronics, it is increasingly important to practice maintenance and repair techniques to extend the life of equipment as effectively and reliably as possible. By engaging with electronic study techniques, an understanding of the function of this equipment can be gained. With this understanding, problems that arise due to faults and issues within the musical hardware can be solved, returning the equipment to service and enabling you to make music without compromise. My name is Samantha, and I am an audio electronics repair technician in Chicago, Illinois. This is my home workbench, where I work on pretty much anything. Synthesizers, drum machines, guitars, amplifiers, speakers, turntables, and a lot of tape machines. Pretty much anything that needs to be fixed. I wanted to take today as an opportunity to explain the function and use of a few tools that are important to electronics repair, so that anybody who is interested can gain some familiarity from which to build a greater understanding. I'll also discuss some of the other philosophical reasons behind the work that is so important to me. The first piece of equipment I wanted to talk about is the oscilloscope. This device displays waveforms under test. It could be an audio signal, such as a guitar or music playback. It could also be from the rails of a power supply to check for faults in the circuit. It can be data from a control CPU and a piece of musical equipment, or even a television signal from a game console. By adjusting the controls, magnification and focus can be maintained in the horizontal and vertical directions, allowing signals of massively varied amplitude and frequency to be viewed with accuracy. I'll be using this to demonstrate other tools and concepts as they come up. On top of it is a function generator, which creates signals that can be used to troubleshoot a piece of gear under test. By observing the signal at various points in a circuit, faults can be detected through symptoms the signal displays. Right now, it's showing a 10 kilohertz sine wave. We can adjust the frequency and the time base of the oscillator to match the oscilloscope. We can also adjust the waveform and the amplitude of that waveform. This piece of equipment is a soldering iron. It generates and regulates a heated tip, allowing a technician to melt solder and use it to connect electrical circuits. The temperature is adjustable, lower for more sensitive circuits, and higher for instances where you might need more power, such as a larger surface or a very thick ground plate. In the same way that a surgeon wields a scalpel and a painter their brush, a soldering iron is used as the primary interface between the circuit and the technician. They can express themselves through the creation of a robust solder joint. The most fundamental of all tools for the electronics repair technician is the multimeter. The two probes connect across 2 points in the circuit and can detect a variety of differential measurements. Signal amplitudes and power can be measured using the DC and AC voltage and current readings, yielding accurate information that sheds light on the function and behavior of a circuit. Additional functions include the ability to test individual components, such as diodes, capacitors, and resistors. I get a lot of questions about how to learn things. I think that curiosity is a really important aspect of being able to study a field like this. So when you find yourself feeling curious about something, just dive in, just look up topics, DIY synthesizer or how to build an amplifier. And then from there, you just start reading and watching and familiarizing yourself with the ideas. As you come across terms that you don't know the meaning of, you look them up and become more familiar. And over time, your knowledge will just grow. And things that were very unfamiliar to you before will suddenly be, oh yeah, I know that guy. And don't get discouraged. It's very challenging, but there's no wrong way to do it. Have fun and sate that curiosity. While I was recording this, my scope started being weird, so keep an eye on that. The study of electronics involves a lot of history, especially when working on designs from as far back as the 50s or maybe even before, that have been designed and reiterated up until the present day. Learning about engineers in the past and the way that they did things can be really informative in understanding why things are done the way that they are today. And there's a lot of techniques that were used in the past that are fun to learn about and are interesting. And it's a really great way to get in touch with that. It's very inspiring to me. It's also quite humbling because there's centuries of information that went into the work that I do today. And I only know this much. The last thing that I wanted to talk about was some of the reasons and motivations behind the things that I do. I think that to repair equipment for a musician or an artist in general is to give them back some of their agency that they may have lost because of a faulty control or an intermittent power cable or a control that isn't doing what it's supposed to be doing, So to return that device to its proper function is to let them get back to their work without having to compromise, without having to accept flaws that are very fixable. Thank you so much for your interest in this work. It's important to me that I not only have my own successes, but pass on that knowledge so that other people who are interested can get an idea of how to get going. At this point, I do freelance repair out of my home workshop, and I also do field work and freelance work for studios and music shops around the city. I've met amazing people and been a part of some really incredible experiences. If this kind of work, or just the study of electrical audio, is something that intrigues you, reach out. Thank you to the Experimental Sound Studio, and thank you for watching.